This video is on piecewise functions. A piecewise function is a function that is composed of two or more different pieces that are defined over different intervals of the domain. So let's take a look at a piecewise function that has three pieces. So here we have, So here we have a graph that has a curved part, a horizontal part, and then a kind of a slanted part. Notice that this curved piece of the function, it's part of the function, the quadratic function y equals x squared. As we look in the negative direction, x continues to head towards negative infinity. In other words, x can be anything negative and getting more negative. In the positive x direction, as we move to the right, you'll notice that my x value stops at 1, at x equals 1. So we would say that the domain for this piece is x is less than or equal to 1. In other words, x can be any value that's 1 or less than it because the graph does not move to the right beyond x equals 1. Notice that the middle piece, another graph here, is a part of the line y equals 3, and that would be this horizontal piece right here. But it's only between x equals 1 and x equals 2 and does not include x equals 1. So the domain for this piece is 1 is less than x, which is less than or equal to 2. In other words, on this interval right here, x can be any number between 1 and 2, not including 1, but it does include 2. And then the far right piece of this function is part of the line y equals x. Notice that this line has a slope of 1. It goes up 1 and right 1. And if we were to continue this line down and to the left, it would go through the origin and have a y-intercept of 0. Notice that it does not contain x equals 2, but all x values that are greater than 2. So the domain for this piece is going to be x is greater than 2. So here's how you write this function in piecewise function notation. F of x is equal to x squared if x is less than or equal to 1. F of x is equal to 3 if 1 is less than x, which is less than or equal to 2. And f of x equals x if x is greater than 2. And those define the three pieces that we saw in this function. Here's one way I like to read it that seems a little less intimidating. Y is equal to x squared whenever x is less than or equal to 1. So I have the graph y equals x squared, but I only want the piece of it where x is less than or equal to 1. Y is equal to 3, which remember is a horizontal line through 3 on the y-axis, but only when 1 is less than x, which is less than or equal to 2, only on this interval right here. And then y is equal to x whenever x is greater than 2. So the line y equals x, the identity function, goes through the origin and has a slope of 1, but I only want the piece of the line where x is greater than 2, hence the open circle. So let's take a look at a couple examples. In this first one, we're going to graph f of x equals x plus 3 if x is less than or equal to 0, and f of x equals x squared if x is greater than 0. So I want to graph the line y equals x plus 3 when x is less than or equal to 0. So the line y equals x plus 3 is going to look like this. Just throw a few dots in here and draw the whole line. Okay. And that's the whole line y equals x plus 3, but I want to limit the domain. I only want the part of this line where x is less than or equal to 0. In other words, I don't want all of this. Okay, so actually a good way to do this if you're doing it in pencil and paper is to lightly draw the whole line in pencil and erase the parts you don't need. But I can't do that here, so I'm going to have to start over, and I only want this part of the line right here. And actually x can equal 0, so I do want a dot there, and I would just continue my line stopping there and continuing that way. So there's the first piece. My second piece is going to be y equals x squared when x is greater than 0. And remember, that's going to be a parabola. okay? But I don't want both sides of it. I don't want this left-hand side of it. I only want the right-hand side because I want it where x is greater than 0. Remember that the vertex for this is 0, 0, but I can't equal 0. It's got to be greater than 0. And a couple other points are 1, 1, 2, 4, and 3, 9, which won't fit on the graph. And so it continues like that. So there's that piecewise function. One piece of it is linear, one piece of it is quadratic. Now let's take a look at a function that's already graphed, and then let's write what this function is. This actually has three parts. So I'll have f of x is equal to, and let's go ahead and define those three parts. So right here I have a piece of the line y equals 4. Okay, so f of x is going to be equal to 4, but only when x is less than or equal to negative 2. So y equals 4, but only when x is less than or equal to negative 2. Now here I have a piece of the line. This is actually the line y equals negative x. And the reason I know that is its y-intercept is 0 and it has a slope of negative 1. So f of x, or y, is going to equal negative x if, and now let's define that interval. Notice that goes from negative 2 to positive 2 on the x-axis, but does not include those two values. So negative 2 is less than x, which is less than positive 2. And then my last piece is this horizontal line down here where y is equal to negative 3, but only when x is greater than 2. So f of x is equal to a negative 3 if x is greater than or equal to positive 2. So not the whole line y equals negative 3, but only the piece where x is greater than 2. So in this video, we took a look at piecewise functions, how it's made up of different pieces, but the domain is restricted on some of those pieces so that they don't continue. Sometimes it's a little easier to think of it in terms of f of x. Instead of f of x, maybe think of it as y equals a function you're more familiar with when there are certain restrictions on the x.